Hi friends, welcome to Mech Plaza. Subscribe the channel for more videos, and after you done subscription you will get an automatic notifications once we upload our next videos. Thanks for your support. So in my previous video I explained about pump affinity loss. So this tutorial is a continuation of the tutorial. So please watch the last tutorial to understand clearly about today's topic. This is my third tutorial. In this tutorial we are going to know about how to find power consumption when changes occurs in speed and impeller diameter. Pump affinity loss for centrifugal pumps. Pump affinity loss when constant impeller diameter. Pump affinity loss when constant speed. Affinity loss while changing both pump rotational speed and pump impeller diameter. Net positive section height versus pump speed. These are the four topics I explained in the last tutorial. So today we will see pump affinity loss example calculation for centrifugal pump. Let's go. As per the pump manufacturer, the pump specifications given as follow. Flow rate Q 100 cubic meter per hour, head 70 meters, RPM 1440, pump input power BHP is 21 kilowatt. Its impeller diameter 240 mm. The pump installed at site and its actual head requirement only 50 meters according to the site conditions. So what is the input power required? So first of all, try to understand the pump was designed, flow rate 100 cubic meter, head 70 meters. But after the installed the pump at site, they found their head requirement is only 50 meters, which means they reduce the head from 70 meters to 50 meters. So during that time, what is the power consumptions? So let's see. To find the power consumption, there are two options. Option 1 is reduces the speed of the pump by using the VFD. Okay. Here H1 is 70 meter, H2 is 50 meter. So consider here the impeller diameter is constant. So the given speed is N1 1440 RPM. So we need to calculate N2 by using this pump affinity law formulas. H1 by H2 equal to N1 squared by N2 squared. So here, so we simplify these derivations for calculating N2 power up 2. So it will be like this: H2 by H1 times N1 power up 2. So just apply the given values to these derivations. 5570 times 1440 power up 2. So once you simplify these derivations, you will find the pump speed is 1217 RPM. So as we know, brake horsepower directly proportional to change in speed of the pump power up Q. So at the same time, power also reduced. P1 by P2 equal to N1 power up Q by N2 power up 3. So here P1 is 21 kilowatt, N1 is 1440, N2 is 1217. This is the one we calculated just before. And P2 we will calculate what is the power changes. So if we just simplify these derivations for calculating P2, we can have P2 equal to N2 power up 3 by N1 power up 3 times P1. So just apply the given values to this formula. So you will get P2 is 12.67 kilowatt. Let's go. So we will do the same by using option 2. So reduces the impeller dia of the pump by trimming. So here we will keep the speed is constant. So we are going to change the impeller dia. So we will use one of the affinity laws. H1 by H2 equal to T1 power of 2 by T2 power of 2. Here the same thing. The H1 is 70 meters. It was already given in the calculations. H2 50. T1 is 240 mm and D2. We will calculate what is the impeller dia. T2 power of 2. So by using these derivations, we will find T2 power of 2 from these derivations. T2 power of 2 equal to H2 by H1 times T1 power of 2. Just apply the given values to this formula. So you will get T2 is 203 mm. So here you have to understand previous impeller dia was 240. Now we calculated once the head decreased to 50 meter, what would be the impeller diameter? So we calculated 203 mm. So impeller dia is decreased, head also decreased. So for sure the power consumption also is going to reduce. So P1 by P2 equal to cube of T1 by cube of T2. Here P1 is already given 21 kilowatt, T1 also 240 mm, T2 we just before we calculated, and P2 we will calculate now. So from this formula we will simplify how to calculate P2. So P2 equal to T2 power of 3 by D1 power of 3 times P1. So just apply the given values to this formula. P2 equal to 203, which is T2 power of 3 by 240, which is D1 power of 3 times 21, which is P1 input power given. So just simplify this calculations. So we will find P2 is 12.70 kilowatt. So the firm affinity laws helpful to trim the impellers at site to suit the actual site conditions, because the motor draws more current than the written by the pump manufacturer. The reason being the actual operating head is much lower than the estimated. Thus the pump operates at excessive flow. Sometimes at actual site, flooded section is available instead of section specified. The pump discharge increases, alerting under such operating conditions, and the motor is likely to get overloaded under the situations. So one of the ways to resolve such problem is to trim the impeller at site to suit actual operating conditions, or installing the VFD. VFD is nothing but variable frequency drive. Installing the VFD by reduce the speed of the pump. Thank you for your support. Please subscribe this channel and give your feedback. We are here to answer your questions. Thank you so much.
Raindrops, drop top, top smoking, no